Hello and welcome to SudoKanard. We are here with another arrow and Kropki Pairs Sudoku, this time in 9 by 9 by Dutch author Wessel Strijkstra from Sudoku Mahabharat. So the rule is still the same, those digits are consecutive. Likewise, they are consecutive here. Those are in a ratio of 1 to 2, so one digit is double the other. And with such a shape, that's not the title of a song. This digit is the sum of all digits along the arrow, and this is it. So this was one of the highest pointers in the round. I didn't have time to work on it, but I wish I had, because I spent too much time on a puzzle that was worth less points. Okay, so where do we start? We can see there are several things to be seen. For example, on this row, we can see that 9 can only be here. 9 can't be with a black dot because we can't put 4.5 nor 18 in a cell. And 9 is too high to be on the stem of the arrow. So stem, yeah, so 9 can only be in the circle. I'm not sure about what I just said, but 9 can only be here on this row. Next thing we can see is that those 5 digits here sum to at least 15. The sum of digits from 1 to 5 plus this is at least 16. So these two cells sum to at least 16. So they are either 7 and 9 or 8 and 9. In both cases, 9 goes there. So this is 7 or 8, and this can be at most 2. Now we must ponder the fact that 8 and 7 must both be somewhere on this column. And a sum of 3 digits, or 3 different digits, will never include a 7 or an 8, because 7 plus 1 plus 2 is 10. So it will be too high. So the second digit from 7 and 8 must be in here, and it won't be 8 because those would have to be 8 and 7. So it will be 7 with a 6. And this is now 8. So now the sum is 17. And those digits are the digits from 1 to 5, which sum to 15. So this is 2. And those must now be 1 and 5, and those are 2, 3, and 4. So that's a very nice place to start. Now let's have a look at this row. We must look for digits 8 and 7. And 7 doesn't go here because 2 is not available. 7 doesn't go here. So 7 is somewhere there. 7 plus 2 is impossible, so it will have to be 1 and 7. And this is now 8. We are left with 3, 6, and 4, 8. This could be 3, 6 or 4, 8, but this can only be 3, 6 among those pairs. And because of this 8, this is the 4, this is the 8. Now this black dot can't have digits from 1 to 4, 8, so they are 3 and 6. 5 and 9 can't be here, so they are there, and this is a 2 together with 1 and 4. But if I try to put 1 here, then the minimum value here will be 3, 4, 5, which is too much. So that has to be the 4. The minimum value now is 1, 3, 5, which means a 9 here, which is also the maximum value. And this is 7, this is 1, and this is 6. 6 is either 2 plus 4 or 1 plus 5, but 1 plus 5 doesn't work here because of those options. So this is 2 and 4, like this. Now we need the 7 and the 8. 8 is not here, so the only place for 8 is here. This could be 1 plus 7 or 3 plus 5. In which case, if this is 3 plus 5, then this is 7 with 1 and 6 there. If this is 1 and 7, then this is 5 and this is 3 with a 2 there. And an interesting point is that we always have a 3 and a 6 here, and a 3 or a 6 here, not both, and the other 3 or 6. So we won't have 3 or 6, 3 and 6. No 3 nor 6 anywhere on the rest of this column. Note that 9 is not here. 9 won't be on the Kropki, so 9 will be there. This is 5, this is 9. There are still a number of options for this and for that, but not that many options. Which is, well, it won't be 3 and 6. It won't be 1 and 2 because there's a 1 or a 2 in here. So it can still be 2 and 4 or 4 and 2 and 4 or 4 and 8. And there is always a 4 in here. So now this won't be 4 plus 5, this won't be 3 plus 6. It can still be 2 plus 7, to here with a 7 there, or 8 here with a 1 there. And here we get a 2, 4, 8 triple, which means that we need digits 2, 4, and 8 to fill those cells. So this can't be a 2 anymore. That's a 6 with a 1 and a 7, and 3 and 5 there. And because of this one, this is now 7, this is 2, those are 4 and 8, this is 3, this is 6, and this is 5. 5 is the sum of those two digits, so this will be from 1 and 3. This is, well, 3 would put a 2 here, which is not available, so that's a 1, and that's a 4, and this is 8, and this is 4, and 4 goes there. Those are not 1s. This is 1. This 9 here goes there. This is 7 and 8. Now this is 1 and 3, but 3 would put a 2 here, so this is 1, this is 4. Now I need 3, 6, and 7. One goes there. On this row I need a 5. Here I need 2 and 4. There's a 4 here. Seven will be, oh, by the way, this 5 disambiguates that. So let's have a look. 2 and 8 must be here. So those are 5 and 9. With a 3 here and a 5 there. Here I need 3 and 6. And here this is 9 and 7, and 6 and 7, and 3 and 6, and by the way, those 6s here on this column. Here we need a 2 and a 3. 1, 4, 8 here. So this is 8, this is 1, this is 4. Here I need 5 and 7. Here I need 8 and 9 to 2, 3, 5. So this is from 2 and 3, this is 5. Note that 2 can't be here because it would have to be with the 3, so that's the 2. 3 and 2, 8 and 2, 8 and 7. Here I need 1 and 7, so 1, 7 there, with the 6 and the 3, 6, 7, 3, and 6 and 3. And that's it. So very nice construction, combining those two types of constraints. Not that easy, but really a nice solving path. Thanks for watching this video. See you soon on SudoKanard.